Hey, how are you?
Doing good, doing good.
Do you have any interviews lined up or are you still preparing?
Still preparing.
Okay, sounds good. So let's go to the code point. So we have an environment that I already see that you have logged in. So
Yep,
thanks for doing that. So I have shared a problem with you. Do you mind sharing your screen with me?
yep. Um, shall we get started?
Yeah, let's go through the problem. Let me know if you have any questions. Yeah.
Yep. So a message containing letters from A to Z can be encoded into numbers using the following mapping: A equals 1, B equals 2, etc., all the way to Z equals 26. To decode and encode a message, all the digits must be grouped, then back, and all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, 11106 can be mapped into AAJF, the grouping 11106, KJF, the grouping 111106. Note that the grouping 11106 is valid because 06 cannot be mapped into F since 6 is different from 06. Given a string as containing only digits, return the number of ways to decode it. The test case are generated so the answer fits into a 30-bit integer. Example 1, string s equals 1, 2, output 2. Explanation, 1, 2 can be decoded as AB, 1, 2, or L, 12. Example 2, s equals 226, output 3, 226 can be decoded as BZ, 226, VF, or BBF. And then 0, 6, 0. Explanation, 0 cannot be mapped to F because of the leading 0. 6 is different from 0, 6. Okay. Yeah, so I think this problem is just asking for, all the combinations or
hmm hmm
all the possible combinations of decoding a message, given, some requirements, like this. So, um, just thinking of any questions that I might have containing only digits. Okay. So I can assume like anything that leads with a 0 can automatically disqualified, right? Because 0
hmm
can't be mapped
hmm
to anything. Um,
Yes. hmm
and then cool. And we just want a to return an integer. Yeah, this all seems um good to me. So now I'm trying to think of what's the best way to handle this. Um, so I'm thinking one way to do this might be just doing something like recursion, right? We have kind of look through all the strings and have like a slate, and if the slate if the number representation of the slate is less than 20, less than or equal to 26, we can convert it into um like a letter, and then we just have, depending on, and then we just iterate through the string, just taking
hmm hmm
like adding to the slate or moving on, like not. So yeah, that's my thought process so far. Um, so yeah, let's get into coding. So we have this function called get decoded possibility count, right? I guess for this, right, is there a function signature like um that the test code the test code needs to pass, or does it not matter what I call this function?
So yeah, I think assume that you have an input like a string, you pass it to a function, and this
Mm-hmm.
function takes a string and it
Yep.
returns the number of decoding as the output. And if it is
Yep.
not possible, you have to return zero. Okay.
Okay. Yeah, that's a good That's a good point. I should have asked for that. If it's not possible, what to return. Okay. Yeah. So we take in a string, and then we want to return a result. So we have this recursive helper that also takes in a string as well as a slate. So I'm just trying to think of the base case here. I think the base case is if the number of the slate is less than or equal to 26.
Mhm.
And yeah, if so, this is not TypeScript, but so usually I would write something like this in TypeScript, but let's just say S is going to be a string and slate is also going to be a string. So we first need to convert the slate into a number, and if it's less than equal to 26, we want to kind of increment a count, or and then we probably need to have like an iterator while we're looping through the string s. So now when we're looking at the string, right, we want to take we want to either take we want to so like given this example, right, on the first iteration we want to add this to the slate, or so yeah, it would either be just taking that single element or
Mhm.
adding it to the slate. So
What do you mean by
uh,
adding this? Either taking one element or adding this to the slate?
yeah, so like when we call the recursive function, right, we would
Hmm.
either take, like for example on 1 2, right, we would either take just 2 or take 1 2.
Hmm. Yeah,
So
that is good.
if the
Yeah,
yeah, if the slate was already 1.
yeah, that is good.
So we can do the slate plus s at I. Oh, sorry. First one is the string, and then the slate plus s of I. Um, um, pass in the count, and here we need to return the count. Pass in the count, and then pass in the iterator plus 1. Otherwise, we take the same thing, but just pass in s of I, pass in the count, and then pass in. We don't want to actually increment I directly here, so do something like that, and then we need to add those together. So we would return the possible combinations of that together. So let's and then if we were to run call this in the helper, we would call the helper in the main function. We would first create a slate that's an empty string, and then return helper, pass in the string, pass in the slate, pass in the count of 0, and then an iteration of 0. So let's see if I covered everything here. Let's run through this one time. So if it's given the first example, it's 12. We pass in the string 1, 2, and the slate is empty. So a number of an empty string, I think in JavaScript, is going to be 0. So we don't want that to increment the count, right? So if we need to check if slate is not equal to empty and the number of slate is less than equal to 26. So yeah, so this would so this left side would be the slate plus I. I guess we possibly might not want slate to start out as empty, since these two would return the same values.
So maybe what you have to do is that go through that step by step, okay? Maybe start with 226, okay?
Mm-hmm.
All right, so input is 226, and then a slate is empty, and then you want to go and call it from line 54. So what's going to happen?
Yeah, so 226, right? We've had the slate is empty, right? Since slate is empty, we bypass this, since this checks if slate is not empty. And then this will be empty plus 2, right? Which would call helper with 2, and then s of I, since I is 0, would also be 2. So we probably don't want slate to start out as empty. We can possibly just get the slate as to be the string of the first character. So we can do like char at 0, or just string of 0, and then we can start at iteration of 1, and this assumes that the string has at least one character. So like if slate, if not string.length, we can return 0. Also, if the first character is a leading 0, right, we can also return 0, because that would make it invalid, right? So now we capture all the edge cases here, and we start at 1. So here the slate would be 2, and the iteration we start at would be at 1. So this first helper will pass in 2 plus 2, which is 22. And the second helper will just pass in the 2, right? So so we would get either 2 or 22 here, and this will make this 2. And then we go through the next iteration, which would be so now I'm thinking of this might not be the best base case, right? Because we do this would only finish immediately, and we still haven't iterated through all of the
Yeah.
the string. So now I'm thinking the base case is probably I is equals to string dot length minus 1, right? So that means we're at the last element. So we would pass in either 2 or 22. So yeah, so we would going through this, right? We would pass in if you start at 2, you pass in 22 or this single 2. But I don't think that accounts for the first 2.
So when are you sure that you are? Uh, so what do you think that you have? Your counting logic should look like. So when you reach to the end of this recursion tree, right, and you are sure that you have scanned the entire string, that means that you have found a new decoding, right?
Yep.
Okay.
Yeah. So
Right.
but yeah, I think we should I think there needs to be another case, right, where we look at both the iteration if it reaches the end, also, but also if the whether the slate is above 26 or not, right? Because we don't want to count 226, right? Because
But
that's not
what do
a
you keep in what do you keep in the slate actually? That is all depends on what do you keep in the slate. Is it just the entire string from the beginning, or is it just whatever that you want to decode?
I think it should be what we want to decode, right?
Hmm.
Um, because so like I guess to do like just to figure out this example here, right? This can be 2, yes, yeah, right here, 226 or 26 and 2 or 226. So for every iteration, right, we can say, hey, we want either the first one, or the first one. Okay, so yeah, we can either see if we would just want to decode the slate or the slate plus the next uh the next iteration, right? So I think instead of s of I, right, it would just be the the slate. Um, yeah, because we would pass in the first iteration. This would be 2, so it'd be 2 or 22. Um, but if it gets over 26, right, we would need to kind of reset the slate.
Yeah, that is the point that your risk. It seems that your slate is accumulating. But from what
Right.
I see is that always it is adding something. Okay.
Yeah. So at some point we need to reset the slate. So so we should only add on to the slate if it's less than 26, right? So maybe you can split this up into two. So you can do like count with addition equals slate plus s of I, and then we only want to do this if the slate is less than 26. Otherwise, the count would be 0. And then we would return the count with addition plus helper of just the slate, not adding anything. Well, hold on. This would be helper as so we pass in 226.
Yeah, I
The
think you have
slate
to be able to, you have to go step by step because debugging a recursive algorithm is a little bit difficult. So maybe you can try to introduce some indentation. So in the beginning, what do you have? So you have a helper. Maybe I don't know. You can say the string is not going to change. So the slate is empty, and you have 0, 1, right? And then maybe you want to say after this, what is your slate? Does that make
it's
sense? So
2.
we can see, yeah,
Yeah,
with it,
yeah,
the two,
yep. Well, I
and
guess
what is
it would
okay. Something like this might
mhm.
be helpful to
Okay.
follow.
Yeah.
Okay.
Yeah, I guess I'm starting out the slate at 2 when the iteration is 1, right?
Mhm. Okay.
And then the next thing we look at is if the count with addition
Mhm.
slate is less than 26. Um uh so yeah, start with 2, iteration 2. Yeah, so this one would be the count would be 2. Um yeah, so yeah, we take a look at this is the count with addition. It's less than 26. So we add the 2 to it, 2 2. Count is still 0 here. And then I plus 1 equals 2, and then we call this again with so we check if Okay. I guess we need to check if slate plus S of I is less than 22, right? Otherwise, it would still call 226. So since it's not, this is this returns just 0. And then so this stops right here, right? And then goes to this the second part of the recursion. And so going back to the up, going all the way up to the call, right? Slate is 2. We have a count of C and I plus 2. So this is just counting 2 as this, and then it goes to 2, and then we can, since 2 is, so yeah, let's hold on, let's write this out. So it goes back here. 2 is less than 2 plus.
So at any recursion level, what option do you have? You have one option is to take one digit.
Mm-hmm. And the other
Okay.
option is to take two digits.
Exactly. And why do you need a slate at all?
Yeah, I guess. Yeah. I guess since we're not recording
Hmm?
what we need to take, um, we don't need a slate. So.
Okay. Exactly. You don't need to kind of decode that. You just want to count the number of valid decoding. So still you have to see
Mm-hmm.
if it is a valid decoding. Okay.
Okay. So yeah, let's remove the slate. But we can still check, right, if string at 0 equals 0. Um, and this is the starting count, and this is 1. So this still remains true. Okay, so either so yeah, so either we take just one number or we take two numbers. So let's so when we take two numbers, right, we have to make sure it's less than um uh less than 26. So if I don't need slate anymore, if s plus, this is s of I plus s of I plus 1,
Mm-hmm.
take the number of that,
Mm-hmm.
is less than equal to 26, right? We call this the this is two number count. pass in the same string, the count, and then the iteration would be I plus, if you took 2, the iteration, we start at iteration 0. It'll be I plus 2, right? Because we already accounted for that. Otherwise, we would just take let's just call it one number count equals 0. Equals helper s c just I plus 1, and then we just return the summation of the two. So one number count plus 2 number count. Okay, let's run through this. So in the beginning, right, we start with just helper of the string. The count is 0. The iteration is 0. So this is just, so here we would first check if 22. So this is 22. Check if less than 26. Since it's less than 26, we would just call h of s count still 0, but we add 2 to it. So adding 2, we would get so adding 2, right, we would get 2, so which it would hit our base case here. But we still haven't checked the last.
Yeah. Okay. So maybe the condition is a little bit, so you have to go one further, right?
Yeah. So it had to be greater than s, or I guess equal. I mean, we just do s equals length, right?
Yeah.
So, so yeah. So now the number of s of I plus s of I. This would be so this would be the 6, right? But s of I plus 1 would go out of bounds. So we need to check that.
You need to check that. Yes.
If I plus 1 is less than s dot length minus 1, and less than equal to s dot length minus 1, and this. So so s plus 1 here would be 3. 3 would not be less than or equal to s dot length minus 1, which would be 2. So we do not call this, and we just call this single 1, and it would call it with stick this plus 1, which would equal to s count still 0, and this would be 3 as equals to 3. So this returns 1, right? And then we go back up to just checking for 2. So we would pass in s count is still 0. And we would pass in this 1 here. So we go here and check. So we go through the next iteration. We check 26, right? It's I plus 1, which would be 26. 26 is less than equal to 26. So we would call h of s 0, 3. So equals the length, we would return another 1.
Mm-hmm.
And then we go back to, so this,
Yeah, I think that is good. It's a good for enough for now. I think the overall structure of the code looks good to me. Can you tell me what is the time complexity?
yeah, so let's see. This is recursively calling so let's see. We can either take 1 or 2,
Mm-hmm. Mm-hmm.
and I want to say it's 2 to the it's 2 to the n, right? Because we have, so like there's 2 possibilities for basically each of the
Mm-hmm.
letters. You either take 1 or take 2. So I think it would be 2 to the n.
Okay, that is good. What
And
about the
then,
space complexity?
yeah, the space complexity is just the stack space. So
Mm-hmm.
yeah, since we don't have any auxiliary space, it would just be a stack space, and the stack space can go as deep as the length of the string, right? Because we're just going one, because one of them just goes 1 by 1.
Mm-hmm.
So
Okay,
it would be O of n as
all right.
well.
That sounds good. Do you think that we can improve this?
There is. I'm trying to think if there's some memoization that we can do.
Mm-hmm. Mm-hmm.
Um, it does seem like we are. Let's. Um, so here we are calling HS of 3, HS03, HS03. But that, I guess that is the base case. So, but I guess if we think about it, right? At some point, like if this was a longer string, right, we would have 0, 2, and then 0, 4, and then if we go 1 at a time, we would get uh, we would hit that 4 count as well. So we can definitely memorize it based on the 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 I count.
Okay. So what is the key? What is the value here? Or
Um,
what do you want to memorize? And I know what do you want to memorize? The value is clear, it's count, but what does this count associated to? So, for example, if you want to memorize one of the
mhm.
things, what would be that thing? Like, is it
Yeah.
I?
So
Mhm.
yeah. So I guess yeah, um it wouldn't yeah. So it would be I in the count, right?
Mhm.
Like the key would be I, and then the value would be count.
Okay, that sounds good. Great. And do you know what is going to happen if you want to do this? What will be the time complexity and space complexity?
Sorry, say it again. If we
So,
memorize it,
yeah, if you memorize that, what would be the time complexity?
um, that the space complexity would be the additional auxiliary space of adding this map, right, of a key value of 1 and 2. I think it would be so it would be all even integers, right? So it would be n by 2. So it would be space complexity of O of n.
Uh-huh.
Um, and then for the time complexity, uh, I want to say um, it would still be 2 to the n divided by 2, since we are, yeah, this one's a little bit harder to figure out, since it is you are
Mhm.
taking half.
Okay, sounds good. Let me spend some time to share my feedback with you. Okay, so I think
Okay, yeah.
your problem solving was pretty good. There are three critical observations about this problem. One of them
Mhm.
is to understand that we need a recursion. The second thing is that how to break down your problem. So we have two ways. One of them is to take one digit and recurse, or take two digits or recurse. The third one is that how to count this. So when we reach to the end of the recursion tree, at that point, maybe we can assume that our input has been entirely, and then we can have a global variable or return a one at that point. Okay. So I think you came up with these observations, but on the coding, it took you longer than expected to converge to a solution. You were lagging a little bit. I think part of the reason was that you were using a slate, and your definition of a slate was in a way that was not exactly compatible with this problem. Like you have to, you cannot accumulate this slate first of all. Otherwise, it's not a valid decision about like if it can be decoded. A longer string, you cannot know if it can be decoded, right? On the other hand, if it is a small, your slate is either one digit and two digits, you could ask yourself, why do you want to have a slate at all, right? You can,
Mhm.
instead of checking for validation at the base case, you can just, at any point, if it is not valid, you can stop. Why do you want to continue, right? So there is not any way that you need a slate at the very end.
Yep.
So you have jumps. Your jumps is either one step or two step, right? So at any
Mhm.
point when you look at that substring, you can check if it is valid. If it is valid, then you continue. Otherwise, just stop that. Stop that, right? So that
Yep.
was the part that you were lagging a little bit. Took you longer than expected. But overall, after these hints, I think that your overall logic and structure of the look of your code looks good to me. So I think time and space complexity was done pretty well. I was happy with that. So we can do memorization as you mentioned. So that was the part that again it was not super clear to you, but after putting some thoughts on this, you notice that we can have an array, and for every I, we can memorize the count associated with that index I. Okay, so Why it is helping? Because we have overlapping subproblems here. So there are some branches that you compute over and over. So if you want to do that, first of all, I definitely encourage you to go and implement this after the interview. But if you want to do this, what's going to happen is that the first time that you reach an index, you make a call to populate that, right? The second time, it's already available. So it means that it is a constant. So the time complexity will be order of n if you think about that, okay? Because you are memorizing, and the second time that you want to come back, you just compute at any index, you compute that once, okay? So this is linear. And the space complexity, the space complexity would be also order of n because you have n indices to compute, okay?
Yep.
So there is another way to solve this problem, and that is using dynamic programming, bottom-up approach. So if you want to do that, again, it's very similar. Conceptually, it's a recursive algorithm that you populate from bottom-up. But the benefit of dynamic programming is that you can bring down the space complexity to order of 1. Why?
Yep.
Because at any point, you need just the last 2 solutions. So dp of n depends on just dp of n minus 1 and dp of n minus 2. Okay, so you can use a circular array or 2 variables to just store the previous solutions. Okay.
Okay.
So I think, I felt that you need a little bit more practice on the coding, and not particularly coding, just how to translate an idea into a code.
Yep.
So this is an example of an include-exclude pattern, as you probably noticed, right? So again, if there is a recursion, just make sure that you think about memorization or dynamic programming if there are overlapping subproblems, okay?
Yep.
And it's helpful if you just think about the time space complexity before starting to code. And the benefit is that if your solution is suboptimal, maybe the interviewer wants to push back and say that I want you to do that in linear time. So for me, it was okay to start with the recursion and then apply memorization on top of that, but generally it's a good idea to make an effort, just not completely block yourself by doing this, but just make an effort to see what is the running time in terms of time complexity and the space complexity. Okay.
Yep. I guess one question is, so let's say like I do the recursive version and I come up with a solution, like I didn't run into any issues, but I couldn't see like the dynamic programming part of it. Do you think that would count against me in the interview, or would that be fine?
So still the interviewer wants you to think about optimal solution, especially because this is exponential and there is an obvious improvement for that. Okay, so you have to think about that yourself. Definitely, you get some good credit for this. If you want to do that pretty smoothly, that is good. But if you don't think about optimal solution, definitely there is some value on doing that, and you don't want to miss that, right?
Okay, but I guess like, what if I think of the optimal solution using memoization but not DP? Like, do you think that would hurt me a lot?
That is good. That is good to my opinion. That is almost as valuable of the DP. So there is some small caveat that the space complexity is order of n, but still, to my opinion, that solution is almost as good as DP overall.
Okay. Yeah. Awesome. Sounds good. Yeah. Thanks very much. Yeah. Have a good weekend.
Absolutely. You too. Take care. Okay.